Hello and welcome to another reverse engineering challenge. In this challenge we'll be looking at Flare 2020 competition and we'll be analyzing challenge number 5, which was called TKApp. So as usual we do get our note, so let's see what does it say. Now you can play Flare on your watch, as long as you still have an arm left to put a watch on or emulate the watch operating system with sophisticated developer tools. And we do get our zip file with challenge files, and it's this TKApp TPK file. So as usual we can run the file command on it. And actually says that it's a zip archive. So actually what we can do, we can unzip it and see what's inside, and actually we can just enter the file in Total Commander as it recognizes that this is a zip file. So we get a bunch of files, and actually in the bin we can see there's a lot of DLLs, and at first I thought it will be a very difficult challenge because probably there will be some kind of operating system or binary that I don't know how to analyze. But when I saw Xamarin, I knew it will be, I guess, .NET related, so won't be that hard. And actually it was .NET related challenge. So we get a lot of those files, and I have them here in the solution folder. So what we can do, we can just take this bin file, probably the main one, and load it into the dnSpy and start analyzing the binary there. So let's just do that. So we can open dnSpy, and I have the file open here, and we can just either go directly to the entry point, or we can just browse through the file manually. But just to get a sense what we are dealing with, you can just see if we can spot anything interesting here. And this is basically like a first check of what's inside this binary. Maybe we can spot something. Here's a password, something that might be interesting. There's also like to-do page. So I guess this application is some kind of to-do application. And also we can see password entry here, and some more decode stuff here and there. So we can see, okay, we have an application, and the app, as it was shown, there's like a function, and I noticed this password here, and that brought my attention to this password. I wanted to see if it's really something I should focus more, or is it just a password in the application, doesn't really is connected with the flag. And if we go to the password, we have the property visible here. What we can do, we can analyze it, and what we'll get all the places where this password is used, like for the getter and for the setter. And for the getter, it's used by and uses, so we are interested in used by. And we can see two functions, get image and pet data update. Let's go to the first one, and we can immediately see that there is something interesting here. I mean, I don't know if it's like a hunch, but seeing something like being generated from a lot of data, and password is one of them, and then it's being passed to SHA-256 to compute a hash, and then it's a key, and we get some bytes. This is something fishy. So that was my first attempt to go after that. So we need to find out how to get this text, because the text is passed to SHA to get a key. So the password is one of those components, but let's just go from the top. So description, we can do the same approach as we did with the password. We just analyze it. Let's now go for the setter, and used by, it's used in this index page, current page changed, and we can see that the description is set to description. And how this description is being obtained? It's obtained from this image 05 JPEG, and it's from this EXIF tags. It's image description from set on this file. So we'll have to mimic the same to actually get the description. So that's one component. We can go back. Okay, the next one is password. So before we search for where the password is used, now we need to see where it's being set. So we go here to the set, we check used by, and we see on login button click. And the password is set to password entry text. So, and this password entry check is checked here. If it's correct, then it's being set to app password. So we need to see how this password is checked. And if we see further, okay, it's comparing password with some data that's being decoded. So this is the data, 62, 38, 63, 63, 54, okay. And what does this util decode? It's just storing the bytes. So we have to mimic the same in our application to get the original bytes. Okay, we have two components. Now we take the third one, which is node. Again, we go to the node, we analyze it, go to the setter and see who is using that, and it's in the setup list. You can see the node is set to be the 0 element of this list 2 and the node. And what actually is being done here? The list 2 is created by filtering list and filtering out those to-dos that are already done. And here we have a list of to-dos with third parameter stating whether it's done or not. So this is done, this is not, this is not, this is not, this is done. So we have to find out which one of those will be our node. And I think that was the one. And the node property is the second one. So keep steaks for dinner will be our node in this example. Okay, we have a node, it's being used a lot of time. Then we have a step. Again, we go, we analyze, just check where it's being set, by who. Pet data update, which is the function that we already saw. And here it's up step is set by application current, application info, metadata it's. Okay, so we need to find out here, we won't be able to go anywhere because the metadata is stored outside of the application. It's stored in XML file usually, or some kind of format that it's used for configuration. So we need to go to our application and just to search for any files that could contain this metadata. And we have the author signature, and TKApp dependencies, JSON, and Tizen manifest. And I don't remember which one of those it is, but actually I found it. So this is metadata, and value for key is magic. So that would be our value. So let's just see what more do we need here. Okay, so we have description, password, node, step. Password we already have, description, okay. So it looks like that we have every component figured out. Of course, we don't have yet the data. We will see in a moment how we can obtain those data in Python. But now this is being passed to SHA to create a key. And then we get bytes from no salt of the earth. But actually what we are being decrypting, because this is just a key, this is like a, I guess, salt or some other data to be used. But where are the data to be decrypted? And the data is actually here. So this runtime DLL is a resource in this binary. So if we click here, we can see it's actually being obtained by resource manager get object runtime DLL. And if you don't know, the .NET assemblies can contain resources inside, and if we go here in dnSpy in resources, we can actually see that we have some XAML files, which is like a UI resources, and we have this TKApp runtime resources, which is TKApp, which is this runtime DLL. And from here, we can actually save this file to disk to obtain the bytes that we need to decrypt. And that's all. So we have a key, we have a text to compute the key, we have the bytes to the salt, and this get string. Actually, yeah, the other bytes are used like the initialization vector, the key, and the ciphertext, and this is just like decryption of this data. So let's see how we can do that in Python. So we can use this exif package to obtain image description, as we saw for the app description component. The node is keep steaks for dinner, as I showed you. The step is magic as the value of this metadata, and the password, which was decrypted with disk soaring, is actually this mullet hat. So I didn't have the code here to decrypt. I decrypted, I guess, in IPython and just put the password here. And then we create the same long text, the same as we saw in dnSpy, and assigned it to test. Then I just print it to have an idea what it is. Then we compute the hash 256 from this test string, and I get the key. I open the runtime, read the data, and then pass it all the information like key and salt, which actually, yeah, it should be called IV, to the EAS, and decrypt the data. And the data is as base 64, because we saw also here that after decrypting, so get string actually decrypts, but then we have to convert from base 64 string. So I also do that the same in my code. So decrypt, just print like 4 first byte to find out what it is, and just save it to result bin file. Okay, so let's just see how does it actually work. So let's go to the solution folder and call solve. We have some runtime error warning. Okay, this is the text that I printed. This is the first 4 bytes, and yeah, we could see that this is like a JPEG file, but we can also run the file command and it says JPEG. So what we can do, of course, we can rename it to JPEG, and if we open the file, we get our flag, never going to recover at flareon.com. And yeah, that was the challenge. I think at first I thought it would be a very difficult challenge with this watch information, that it's some kind of might be a binary for a watch, as yeah, I didn't have any experience with that. But yeah, when I discovered that it's really .NET related, that was fairly easy challenge to solve. There was not that much hidden, just there was just the part of extracting information and running relevant algorithms. So yeah, that's all. I hope you liked the solution. If so, please like and subscribe, and see you in the next challenge. Bye bye.